Hey Chem students, this is a video on writing orbital diagrams. So you've been writing electron configurations like your 1s2, 2s2, 2p6. Remember, this is telling where electrons are located. The orbital diagram is going to include one more thing called where electrons are located within an orbital. So let's say we have helium over here, which has two electrons, and they are located in the first energy level, s sublevel, which is spherical in shape. Within sublevels, there are things called orbitals. An orbital holds two electrons. One orbital holds two electrons. Okay, it's just like a spot for electrons to sit. So I draw an orbital like this. Let me just see a box drawn. Okay, and then we draw the electrons in there. Well, there's two electrons in this S. We draw them with arrows. That's an electron spinning clockwise. That's an electron spinning counterclockwise. So they have a magnetic spin to them. Electrons do. So this means in the first energy level, S sublevel, there's one orbital. So that's an orbital. And that's an electron spinning clockwise, electron spinning counterclockwise. There's two electrons in there. If you have a two with that, that's okay as well. Okay, so let's think about how many orbitals are in each sublevel. An S sublevel has one orbital. A P sublevel, which holds 6 electrons, would have 3 orbitals. Okay, each one can hold 2 electrons. A D sublevel would have 5 orbitals, and an F sublevel would have 7 orbitals, since there's 2 electrons in each one. So let's say there's a couple other rules to that. Let's say we have an element like phosphorus right here. Okay, so if we do noble gas configuration, we go neon in front of it. So that means we're skipping the first 10 electrons of phosphorus. All we're worried about is those last electrons. So the next electrons are in the third energy level, S sublevel, so 3s2. So there's one orbital in S sublevel. 2 electrons are spinning opposite directions. And this is called the orbital diagram, showing the orbital. After 3s comes 3p. And in the 3p sublevel, phosphorus has got 1, 2, 3 electrons. So we draw all 3 orbitals that AP would have. It can hold up to 6 electrons. Here's the deal. Electrons want to go into orbitals unpaired when possible. So they want to go in by themselves. So one electron goes there, one goes there, one goes there. I don't care if the arrow is up or down. Electrons want to be by themselves when possible. So phosphorus has got 5 valence electrons, 2 in the S sublevel, 3 in the P. If we draw the dot diagram of phosphorus, it's got 1, 2, 3, 4, 5 valence. I'm not sure if we've drawn that yet in any videos, but the dots are always the valence electrons, which are the most important ones. It's outermost energy level. These 2 paired electrons are these 2 electrons. These 3 unpaired electrons are these 3 electrons. If we were doing sulfur instead, sulfur would have a 4th electron, so one of these would have an extra electron in it now paired up. So if we do sulfur's dots, sulfur would have 1, 2, 3, 4, 5, 6 valence electrons. We also can tell that because it's in the 6th or 16th family. These all have 6 valence electrons. These all have 5 valence electrons. These all have 4. These all have 7. These all have 8 valence electrons. So we can tell it off there. All right, if we do a different element, let's say we do cobalt right here. So noble gas comes before it is argon. So remember, that means we are skipping the first 18 electrons. After argon comes 4s2. So 1 orbital, 2 electrons with opposite spins. After 4s comes 3d. Remember, this is the 3d. 3d from there to there is 3d. Third energy level, D sublevel. And D's can hold 10 electrons, so we're going to have 5 orbitals. Sorry, I'm getting down in the periodic table there. We go 1, 2, 3, 4, 5, 6, 7 for cobalt. That means we're going to go 1, 2, 3, 4, 5, 6, 7 electrons. Some electrons want to be unpaired when possible, so there's 7 of them in there. Valence electrons are always the outermost energy level. 4th energy level, 3rd energy level. Outermost is the 4th energy level. Outermost is 4th, so these are the valence electrons for cobalt. So if we draw 3 valence electrons, it's got 2 valence electrons. 2 valence. Fairly brief video on orbital diagrams with the dot diagrams. So have a good day.